This video, we're going to talk about vector projection. So let's say you've got a scenario where you're trying to pull a box along a floor with a force vector of u. So as far as the box is concerned, the box only cares about this force here. It doesn't care about the force you're actually giving it. Even though you're giving it a vertical lift, the box doesn't really care about the vertical lift. It wants to move in this direction. It only cares about moving in this direction. So the only force that the box cares about is this one here. Is this one here. And by the way, this force here will be weaker than the actual force you're giving it. So to obtain the strength, to obtain the strength that the box is interested in, to obtain the strength, you would at the moment this is a vector. This force is a vector. So to obtain the strength that the box is interested in, you would extract the magnitude of the vector force. So at the moment this is a vector. So you would extract the magnitude, the strength. You would extract the strength, and then you would times by cos the angle, whatever the angle may be. So this thing here represents the strength in this direction. In this direction, the box doesn't care about this force here. The box only cares about this force here. So we would start out with a force, but then we are not interested in this force. So we would project this force onto a new vector that we were interested in. We're going to define this vector v because v here represents the direction in which we are interested in. We would define v to our convenience. Okay, so let me give you another example. So let's say now you're trying to pull it uphill. So there's an angle associated with this. So you're trying to pull it uphill. But as far as the box is concerned, it only cares about this force here. It doesn't actually care about the actual force you're giving it, because this is wasted. You giving it a slight lift, it's being wasted. As far as the box is concerned, it wants to move uphill. So it only cares about this force. Well, this force here, at the moment it is a vector. So we would extract the magnitude of this force. So we would extract the magnitude. So to extract the magnitude, we would do this. So this is the magnitude. So that's the magnitude. And then well, the box only cares about this force. The box only cares about this force. So it would be the magnitude times cos of this angle, whatever this angle may be. So this is what the box is interested in, this force here. So we would project the vector u onto the vector v, Well, this thing here represents the strength of this force. So it represents the strength. It represents the strength of the force that the box is interested in. The box is not interested in this force. But the thing is, now the direction would be. Remember, we would define v to our convenience. So we're going to define v in this direction here. Well, to obtain the direction, we would get the vector v itself and then divide it by its magnitude. That would then give us the direction. And we've done this before. Remember when you have a vector, let's say this vector here, to obtain the direction, let's say it has a magnitude of 3. So you would get the vector itself, and then cut it up into 3 equal pieces. Then this has a length of 1. So basically a length of 1, meaning this thing here would magnitude here. Sorry, hang on. So this thing here would represent the direction. So now, well, if this represents a strength, hang on, let me start again. We are the box is only interested in the strength here. The box is only interested in this vector force. So we would extract the magnitude, which is this bit, times cos theta. That would then give us the strength. That would then give us the magnitude of this thing. But now, because we want to tie it into the direction, we want to tie the strength of the of the force into this given direction, So we would times it with this. Remember, this here is just a direction. This is a strength. So now when you read this, it's actually the strength here in this direction. I will continue in the next video. So we are currently here at the moment. Okay.